Thank you, Sharma sir. I thank the organizers for General delay. Before I start, I just want to narrate a little story. You know, a guy was going to a party and he decided to make a grand entrance. So he went by a hot air balloon. And when he went up, he got lost. And he couldn't identify anything on the ground. Then he saw one man on foot walking. So he said, lower his balloon to that guy and says, where am I? So he says, at precisely 10 degrees, 5 minutes, 23 seconds north, and similarly some minutes, degrees east. So he says, you must be an engineer. He says, very right, how did you guess? He says, because you've got precise information which makes no sense. So he says, you're right. And he says, you must be the corporate manager. So he says, that's right. He says, how did you guess? He says, because firstly, you need hot air to take you up. When you go up, you don't know where you are. You got to come down to Mother Earth to know where you are. When you are given precise information, you can't understand. So that is the nutshell of technology, of information, and actually the whole subject that we are talking today. Information has to be of use, and information has to be precise. There's nothing more for me to say on target acquisition and weapon guidance at the moment, because after such illustrious speakers who left nothing uncovered, I will concentrate only on the simulation part. And there may be some reference to target acquisition and weapon guidance, which I will skip because it's very rudimentary compared to what is covered by the most worthy speakers on the dais. Okay. I'll have to read from there because my thing is coming very small here. Why actually do you need simulators? My talk is more on simulators. Why do you need simulators? How do you need to prepare for war? Firstly, will a soldier experience war and take all his decisions at the first time during war? If it's not going to happen during war, then how else can it get experienced? So that is when you create a simulate warlike situation, and that is the importance of simulators. You teach him to overcome fear. You teach him to fight through shock and threat, and see what's next, and to avail any opportunity that just sweeps by. Training, kill on the first opportunity, and practice it during peacetime. That is the importance of simulators. So what are the requirements of the simulator? Basically 4 requirements. You need, firstly you need the environment. You've got to create the environment. You've got terrain, weather. Gentlemen, I'll go very far because most of what I'm covering is very rudimentary and compared to what we've heard from the other speakers. The vision, the electromagnetic environment and propagation. These are the things that you have to simulate. Thermal, the environment. Thermal environment not only of the target, of the whole environment, because you've got to see the target through the environment. Sound, somebody spoke about acoustic sensors. Targets, you've got to simulate targets. They're flying objects, aircraft, helicopters, UAVs, missiles, etc. Their shape and their optical projections, how they look from various angles. Shapes, I've covered that. The material and how to identify what material it is, how it would reflect, etc. What radar apertures would it give, what thermal signatures it would give. Electromagnetic and thermal projections, I've covered that. Flight dynamics, how they fly, where are they going to be next, how to identify, because when you fire a projectile, you've got to decide if, of course, its own, the projectile, if it's not guided, you've got to cater for where the target is going to be, where it's going to get hit. And that simulation has to be built in. You've got to get his flying profile, and then it will be. And of course, various protection systems that the object may have, ECM, ECCM, active, passive protection, etc. I'm finding it a little difficult because I can't read it here, and I couldn't put it on the other one because I'm using a Mac and it wasn't compatible. Sensors. You need to what are the sensors that you need to simulate? Human sensors. A guy is seeing it, he's hearing the sound. Optical, electromagnetic, radar, direction finders. Somebody mentioned about the next generation of precision guidance, maybe electromagnetic. Thermal sound, weapon systems, their propulsion, their ballistics, flight dynamics, warhead characteristics, how a particular warhead will affect the particular target, what damage it will cause. Requirement of air defense simulators. Firstly, the major components, the GIS engine and the 3D virtual world, same graph. Now, this is the crux of the simulator. Actually, the whole simulator is built on the digital terrain. And that is the relevance to this particular seminar. Airborne target models, I will show you some of them. Air defense systems, models of missiles and guns, surface air-based sensor models, communication system models, electronic warfare, surface and air, environmental models, time of day, weather, optical, electromagnetic, thermal propagation models, and finally to get to the single shot kill probability. And everything else will come up after you get the SSKP. Functions, what it can be used for, what the simulator can be used for. Plan and deploy air defense assets. Now, planning and deployment of air defense, this is something that I want to cover. You see, most of the air defense assets, firstly, using radars, for example, you need a line of sight to the target. And nothing can do it better than putting it on a digital terrain first to see what you will cover. You can get an exact coverage if you put it on digital 3D terrain. So you can plan where to deploy and how to cover the whole area, where they need to be deployed to be able to cover the particular area that you want to cover. Plan airborne missions. Now this is not only, the air defense is also applicable to the Air Force. So you plan the missions, the electromagnetic and IR environment simulations. In fact, we've done another project which, for some other directorate, where we've done simulation of the electromagnetic battle space. Complete all propagation models, if you transmit at a particular point, a particular frequency, how it will affect the environment, what will be the signal strength at various places, which sensor at which place will get what. All that models are there. Weapon launch, fire and kinematic modeling, visualization in 2D, 3D, analysis and after action reports. Total effect simulation. AD ground environment simulation, computation of operational envelopes of AD assets, and planned and map-based deployment, models of sensor seeker heads, guidance system modeling, warhead, trigger mechanism modeling, models and communication hierarchy in the C3 structure, computation of operational envelope based on deployed terrain and capability, deployment of AD missiles and gun systems. Now all this a total simulator can involve all this. Deployment of radars, communication equipment and EWSs. Mission planning, I think I won't elaborate on this. Electromagnetic environment. The EM environment simulation provides an integrated system for real-time planning and management of the electromagnetic battle space. Now here, This is, even it helps you with your spectrum management, helps you with the deployment of your emitters at various locations, and even when you deploy AD assets, which radar can interfere with which radar itself, and what aircraft flying with what characteristics will affect the radars, what reflections you would get, what would be the RCS detected, because every time you do not get the full RCS of the target. It also, all the night rays, refractions and diffractions and so on, all that modeling is there for this, for the total effect simulator. IR optical sensing, I think everyone has spoken about it. The visualizations, what you would see on various sensors, whether you see it with your eye, whether you see it on the radar scope, or what you see, or whatever, and how you're going to get the picture. Now, what are who are the users? AD strike planning, air tasking cells, fighter controllers, air defense weapon system operators, missile guns, radar operators, mobile observation post operators, C3 and base AD operation hierarchy, AD tactics, development, establishment of Army, Navy, Air Force, and weapon system deployment laboratories. Now, I will come to the experience of my company. Air Defense Classroom Simulator, the gentleman spoke about, we supplied it to the Air Defense. Aircraft recognition and training simulator, we have developed it. We went through the trials. VSHRAD simulator for the IGLA. Again, this is a project for the Air Defense, the Army Air Defense Center in Gopalpur. We developed one. System for management of the electromagnetic battlespace. We have a complete system which has been field tested. And radar data processors and multi-sensor tracking. We've done this for the Air Force in the IAWCS program. I just have some, unfortunately I don't think videos are going. Okay, I think it might come. As you see here, you see there are some AD resources deployed. You see the AD resources deployed, and you've got the aircraft, 2 missions, 2 aircraft, 4 missions, and heading for this AD resource. Okay. So those are moving towards the, this is the way the exercise is set up. You've got all the this is on a 2D platform, at a 2D terrain. And you plan on the fly, you can pre-plan your EW operations, or you can do it on the fly. In this case, we've done on the fly. You're selecting that you need to jam the particular target. So you're carrying out the jamming, you're selecting the various pods, you're selecting the type of jamming to be used, you're selecting the frequency, and you're carrying out the jamming. Now you see that there are 4 aircraft and there are 2 aircraft going. So here you are seeing it on one of the radars. Now these pictures are from the computer, from the simulator. You see, as you see here, and now the jamming, this is how you see the jamming, the major lobe and the minor lobes. And the action taken by the operator switches on, comes on to the second magnet one, and he avoids the jamming because it's at a particular frequency. And again you start seeing the targets. Similarly, on the another platform, here of course you also got the optical sensor. Now there's a previous model which showed just the aspect of a single aircraft. The modern one, the new one that we have, it shows all the complete flight characteristics. Again, the jamming, and here you see that it is being, there's a different way of getting all the jamming here. Now this is the aircraft mission, this is for the aircraft recognition trainer. You've got, you've made a flight plan and you put observers. So the observer who can see the aircraft is in green and the other ones are in red. I have another one. So you see the aircraft moving, there's a mission moving and the observer there is watching it. If you've got the various waypoints connected, of course the aircraft can't take the sharp turn, but it has to touch the waypoint. So it touches the waypoint and uses its own flight characteristics to turn and head for the next waypoint. And all these things are possible. Here you can change all the parameters of the flight, and you can all those things you can do on the fly, or you can pre-program. These are the various aircraft models. How it would look like to the observer on the ground. I think I will just show one video. I don't see the sound. Okay, it's got complete positional sound, surround sound, and all the Doppler effects, etc., all being modeled. And you are seeing it, one observer has seen it, then it goes out of the range of one observer, it goes to the other, you've gone to the other observer, and you are seeing the aircraft coming. This is the actual terrain at that particular point, from where the observer is, how he would see them, how we would identify what aircraft they are. Similarly, for helicopters, I won't show you this. And we've got automatic, you can use binoculars, so you can simulate the binocular effect. This is the IGLA side of this thing, except this is of course, we haven't developed this completely, we got it from a partner abroad. And the difference is that instead of the screen, we are putting a small monitor on the missile itself, which will, we have to modify it as per the requirement, where you've got a camera and the camera is sensing, it's got two-axis camera, which is exactly giving you where it is pointing, and the targets are being simulated, whereas the camera is picking up the actual terrain. So you've got the actual terrain with targets simulated, and the camera giving you the position. This is the effect, let's say, of the radar, how the electromagnetic effect that it creates. This is calculate the power that you get at a particular place. These are the radar data processors that we've done for various sensors for the Air Force. The Air Force, in fact, the IACCS, all the RDPs are being given by us. And the MST, which we have installed in Southern Air Command. I come to the last issue of my point, since I have had the opportunity of having the DGAD. I think the most forward-looking armed service at the moment as far as acquisitions are concerned. You see, there are constraints. All the time we are talking about 70% import and 30% Indian and how to increase it. But the model that we put across in the DPP doesn't make it easy for the industry to be able to increase the production and increase the indigenization. Because the costs involved are so great and the uncertainties are so much that the risk is so much in investing in defense production that people are reluctant. That is the main problem with our procurement procedures. And therefore, if you see here, if you need something, now you do a multi-vendor situation, 6 people produce the same equipment, you can select one, what happens to the other 5? The other 5 have wasted their effort. Such a thing is avoided in the turnkey projects, where you only do the TEC and you have to make one guy do it. But again, the issue is he does it by himself. The army cannot pass on the domain knowledge, and therefore I am of firm opinion that everything has to be developmental. You've got to choose a partner, and what the chief mentioned in the morning, the public-private partnership. I think that's the only way forward, that the Indian industry will become world standard and will be able to give you what you want and be able to upgrade it continuously. and give you, keep on giving you newer and newer things. As you see all the operating systems from DOS to Windows 8, how they progress, Microsoft. Similarly, I think somewhere you've got to make centers of excellence. You've got to get into a public-private partnership, select a partner who you think has got the capability, and then go ahead and keep on passing, because I can tell you one thing, that domain knowledge is so important, and the service officers have so much domain knowledge which is not being utilized in the industry today because of the current model. And this can be utilized if we go into that PPP model. That's all that I have to say. Thank you.